Welcome to Math with Mrs. Bibb. Today we will be talking about relations and functions, how to represent them, how to recognize them, how to evaluate them. I want to also remind you to please make sure that you go to the document in Google Classroom and fill in the page number for your video for today. We're going to define relation, domain, and range. A relation is a set of ordered pairs. The domain is the set of x values of a relation. And the range is the set of y values of a relation. When we list the domain and range, normally it is done with braces, and within here is your set of values, and you'll list them in numerical order, smallest to largest, separated by a comma. Relations are represented in multiple ways. This first way is called a mapping. The second way is called a table. The third way, obviously, is a graph. And the fourth way is an equation. All of those are called relations. We're going to express this relation as a table. X and Y. X goes on the left. Of course, the textbook does a fancy table and makes a box. If you want to make a box, you can, and then separates them. That's a table. Then they make a graph. To 0. Origin. Let me switch colors so I have a different color. Go to the origin, count right 2, put a dot. Go to the origin, count up 4, put a dot. That's 0, 4. Go to the origin, count right 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. Line it up. And then -3, -5. Go back to the origin, go left 1, 2, 3, and down -5. That's the relation listed as a graph. And then the last thing is a mapping. Let's put them in order. I know the table didn't put them in order, but let's put our x's in order. And sometimes they put domain and range. Sometimes they put it in a little oval. Sometimes they put it in it's just, whatever you want to draw is fine. I'm going to put -3, 0, 2, and 3. And then I'm going to put the y's in order also. That would be -5, 0, and 4. So -3 goes with -5. That's a mapping. 3, let me go to 0. 0 goes with 4. 2 goes with 0. And 3 goes with -5. So that's the relation as a table, a graph, and a mapping. Next, we're going to determine the domain and range from example 1. So if you'll look back at example 1, the domain is the set of x coordinates. And those x coordinates in order from smallest to largest: -3, 0, 2, and 3. That is the domain, the set of x coordinates. Make sure you use braces around it, and make sure your numbers are in numerical order from smallest to largest, separated by commas. And then the range, and you do not have to write this down. I just wanted to make sure that you understood the ranges and domain are listed this way. When you're listing the set of x or y coordinates, make sure you put the braces around it. And then the set of y coordinates are -5, 0, and 4. You should write the following in numerical order. Smallest to largest. And most importantly, do not repeat domain or range values. Okay, next. We're going to list the ordered pairs in each relation, and I know you have room to the right. So from the table, we're going to list those ordered pairs. It looks like -1, -5, 4, 7. Hope there's no negative on it. I can't see past my little toolbar there on the left. And -2, 3. -2, 3. That's the ordered pairs there in the table form. From the graph, -1, -2, -1, -2, -3, -4. Is that right? -1, -2. So it's -2, -1, -2, -3, -4. Okay, and then -1, 1, 2, 3. -1, 3. And then from the origin, 1, 2, 3, 4, 5, and up 1. And then for the mapping, the ordered pairs are 1, 5, 5, -1, and -6, -1. Next, independent variables are usually x. It has a value that is subject to change. And the dependent variable is usually y. And this is what I say to remember this. Y depends on x. So y is dependent and x is the independent. Y depends on x. Now let's look at example 4. It says the graph represents the number of text messages sent by Nora throughout the day. So the first thing we want to do is identify the independent and dependent variables. So independent and dependent variables. not only will we indicate if it's X or Y, but we will also tell what that stands for. So this is, of course, is my x-axis. This is my y-axis. So my independent variable is the time. And that, of course, is the x. And my dependent variable is the number of text messages sent. And that's the y. And it says describe what happens in the graph. So we'll write that question out. So as you move from left to right, as you move from left to right, the time is increasing. So as you're moving from the origin to right, your time is increasing. And as you follow this line, as the time is increasing, what's happening to the text messages? They're increasing. So from here to here, this would, I would imagine, would be wake up time. And then when you first wake up, you send your text messages. Then it levels off a bit, maybe to travel to work, and then, or to school. And then you're there for a little while before the bell rings. So your text messages increase. And then it levels out because you are working or in class and you don't have time. And then as the evening goes on, then your amount of text messages increase. So if you will paraphrase all that I said, find some way to put it in 2 or 3 sentences and put that here. I'll be looking for those sentences to see how you paraphrased everything that I just said. If you need to rewind to hear that again, then please do. And then we will go on to the next slide. A function. A function is, I'll give you the fancy definition first. There's exactly one output There's exactly one output for each input. I want to show you something that helps us remember things. In an ordered pair, we have X, Y, domain and range, alphabetical order, input, output. There's exactly one output for each input. Another way to say this, that's one way. Another way is each element of the domain is paired with exactly one element of the range. And another way to say it, no X value repeats. That's if you have a relation listed in a set of ordered pairs. No X value repeats. And you can also say if you have a graph, that graph passes the vertical line test. We're going to look at the next example and decide if these are functions or not. So as I look at this first example on the left, would this graph pass the vertical line test? Yes, every single vertical line that I have drawn only passes through the blue graph one time. All those vertical lines, no matter where you, whoops, that's not there. No matter where you would draw a vertical line, it would only pass through one point on the graph. So that means that this first one is a function. Would this one pass the vertical line test? No, so it's not a function. And Next, we have a relation in the form of a mapping. If it's easier for you to see by making a list of ordered pairs, then please do. So I've got -4, -1, -2, 3, 2, 3, and 5, 6. Did an x value repeat? No, so this is a function. Then when I look at the next example, I have a table. The domain are my x values, and 2 x values repeat. So that means this one's not a function. And next I just have a relation that's a set of ordered pairs. Do any of my x values repeat? No, so this one is a function. Example 2. Schools are competing in the long jump portion of a track meet. The distance of the players with the best jump on the team are as follows. Team 1, 20.6 feet. Team 2, 21.5 feet. Team 3, 20.9 feet. Team 4, 19.4 feet. And Team 5, 20.2 feet. So the first thing I want to do is make a table. I'm going to use that information. I'm going to put my team in the top as my x's, and I'm going to put my best jump in feet across the bottom as my y's. So I've got 5 teams: Team 1, Team 2, Team 3, Team 4, Team 5. And if you want to make a nice pretty box, you go right ahead. But that's sufficient to me. And then Team 1, the first jump is 20.6 feet. Team 2, 21.5 feet. Team 3, 20.9 feet. Team 4, 19.4 feet. And Team 5, 20.2 feet. What is the domain of this function? So we do want to name the domain. The domain is the set of x values, 1, 2, 3, 4, 5. The range is the set of y values in order from smallest to largest. Looks like 19.4, then 20.2, 20.6, 20.9, and 20.4. 1, 2, 3, 4, 5. Yes, those are my 5 numbers. And then, is this a function? Do any of the x values repeat? So none of the x values repeat, therefore it is a function. Next we have 6x plus 2y equals 14. Is this a function? All of my examples here are equations of lines. If your line can be written in this form, y equals mx plus b, then it is an equation of a line that is a function. So if you look at this first one, 6x plus 2y equals 14, I can subtract 6x. 2y will equal negative 6x plus 14. I can divide by 2. So y will equal negative 3x plus 7. That is an equation of a line. It has negative slope, so therefore this is a function. Y equals negative 2. Yes, it can be written in that form. Y equals 0x minus 2, because the slope is 0. If you don't have an x, then the slope is 0. So yes, this is a function. And the last one, you cannot write that in the form y equals mx plus b. X equals 4 is a vertical line, and that vertical line would fail the vertical line test. So this one is not a function. If you have x equals something, that will not be a function. Oh, negative 3x plus 7. See it there? Negative 3x plus 7. Next, function notation. Function notation. I've got several things I want to write about function notation. It is a fancy way to write a function. And from above, we've got the equation y equals 3x plus 7. Let me go back. Y equals negative 3x plus 7. The fancy way to write that is f of x equals negative 3x plus 7. And above we had y equals negative 2. The fancy way to write that is g of x equals negative 2. You use different function notation forms. That way you can have multiple different functions listed. And I want you to remember, you read it f of x and g of x. That's not f times x, that's not g times x, that's f of x and g of x. And hopefully you can notice, I'm going to grab a highlighter, y and f of x are the same thing. Y and g of x are the same thing. So that notation is just fancy notation for y. So f of x and g of x are both the same thing as y. Then when you evaluate functions, you evaluate them using substitution. You usually have f of x. In place of x, you're going to put 4. And when you read that, you read it f of 4. And let me translate this. This is what this says. Find y, so this whole thing is find y, comma, when x equals 4. So don't forget that. Find y when x equals 4. You're not solving for f, you're finding y when x equals 4. So we're going to go evaluate some functions. So we're going to use the f of x function and the h of x function to evaluate. Number 1 says f of 4 plus 3. So what I'm going to do is I'm going to substitute 4 in for x. So negative 2 times 4 plus 9. And then I'm going to add 3 on the end. I'm going to multiply first. I'm going to add the first two together and get 1. And 1 plus 3 is 4. So f of 4 plus 3, that value is 4. That's the final answer. Next I'm going to do f of 5 minus f of 1. So I'm going to substitute 5 and 1 both into that f function. So negative 2 times 5 plus 9 minus, and I'm going to put parentheses because I've got to make sure to subtract that whole value, negative 2 times positive 1 plus 9. I'm going to multiply and get negative 10 plus 9, and that first thing gives me negative 1. I'm going to subtract negative 2 plus 9. Negative 2 plus 9 is 7. Negative 1 minus 7 is negative 8. And please let me know if I make a mistake, because sometimes I just get so excited I just keep going and I make mistakes and I don't mean to. Now we're going to substitute 2 into the h function. So negative 6 times 2 squared plus 18 times 2 plus 36. Order of operations, PEMDAS. I don't have anything to do in parentheses, but I do have an exponent, so I'm going to do that first. 2 squared is 4. I'm going to bring everything else down. Next, I'm going to multiply negative 24 plus 36 plus 3. Then I'm going to add negative 24 plus 36 is 12. 12 plus 3 is 15. So h of 2 is equal to 15. Now h of 4 minus h of 1. So h of 4, I'm going to substitute 4 in here, plus 18 times 4 plus 36. Let me go ahead and do that value first. So negative 6 times 16 plus 18 times 4 plus 36. 6 times 6, 30. So negative 96 plus 72 plus 36. Negative 96 plus 72 is negative 24. I think so. Let me know if I'm wrong. Plus 36. So h of 4, all that work is for h of 4 is 12. Minus h of 1. So I'm going to try to squeeze that here. Negative 6 times 1 squared plus 18 times 1 plus 36. So negative 6, 1 squared is 1. So negative 6 times 1 plus 18 times 1 plus 36. And I'm going to multiply. Negative 6 times 1 is negative 6. 18 times 1 is 18 plus 36. I'm going to add negative 18 plus 6 is 12. And 12 plus 36 is 48. So I've got 12 minus 48, which I believe is negative 36. 12 minus 48 equals negative 36. Let me know if I have added or subtracted incorrectly in my mind. So this final answer is negative 36. Okay. Did I make a mistake? Oh, I see a mistake I made. Oops. Hold on. This should have been 36. This should have been 36. And that answer changes, so I really did make a mistake. But I found it before I was done. 12 plus 36, actually. Yeah, 12 plus 36, because negative 24 plus 36 is 12. 12 plus 36 is 48. So make sure you fix that. I did do that one incorrectly. So I've got 48 and I've got negative 36. And now I'm going to do h of 5 minus 7. So h of 5, negative 6 times 5 squared plus 18 times 5 minus 7. So negative 6 times 25 plus 18 times 5. It's about to make another mistake. Hold on. This should be plus 36 and then the minus 7. Then plus 36 and minus 7. And then negative 6 times 25, I think is negative 150. Plus 90 plus 36 minus 7. I'll do these two first. I think that's negative 60. Then I'll do these two. That's negative 24. And that answers negative 31. So that's the answer to those three. And now on to number 6. We're going to look at this word problem. Mason works at the movie theater after school. The function g of x equals 9.25x represents the amount of money he makes before taxes for each hour that he works. Evaluate and interpret the function for each value. So I'm hoping that you can look at this and see how much Mason makes per hour. So think about that. How much money does Mason make per hour? And hopefully you can see that that is $9.25 per hour is how much Mason makes. So I'm going to do g of 8. 9.25 times 8. And 9.25 times 8 is 74. Now what does this mean? We're going to interpret it. It means when Mason works 8 hours, he earns $74. G of 14. So G of 14 is going to be 9.25 times 14. 9.25 times 14 is 129.5. When Mason works 14 hours, he should get paid overtime, don't you think? When Mason works 14 hours, he earns $129.50. And then G of 27.5, of course all of these are before taxes. So G of 27.5, this would be hopefully how much, well of course not how much you'd work in a day, because that's more than a full day. 9.25 times 27.5. When you multiply that, you get 254.375. And I kind of ran off the page. 254.375. So we would say that when Mason works 27.5 hours, he earns $254.38. $254.38. And that is all the notes. I hope you have a wonderful week.